about inverse circular functions today, inverse trig functions. We have kind of done some of this. So we know from algebra, an inverse is like the opposite. Okay, so we have had problems where I might say sine theta equals 1/2 in quadrant 1. And you had to tell me what the angle was that made sine equal 1/2. So that's actually doing an inverse. So when we're solving these inverse problems, we are finding an angle. So it goes back to knowing those unit circle values, which is why the last chapter I had that handout that we were doing 5 problems every day, just to kind of keep those fresh. If you're rusty on that, you might need to pull out a copy of your unit circle. You know that on a test or quiz, you could have a blank copy, but you still have to be able to fill it out if you're going to use it. Now, with inverses, we have to be a little bit careful, because if you remember from algebra, not everything had an inverse. In order to have an inverse, a function had to be 1-to-1. So a 1-to-1 function means that y never repeats. And the reason this is an inverse flips x and y. And so if you take something that is not 1-to-1 and flip it, it will no longer be a function. For instance, like in algebra, one of the common examples we used was a parabola. You know, we talked about if it's 1-to-1, it passes the horizontal line test. Okay, can we agree this would not be 1-to-1 because we hit the same y value more than once? When you try to find the inverse for this and flip x and y, it turns that parabola on its side. And what's wrong with this?
It doesn't pass the vertical.
Yeah, that fails the vertical line test. And so it's no longer a function where if you plug in 1x, you get 1y value back. So that is an important piece. We use that horizontal line test to determine if things are 1-to-1 or not. And in order to have an inverse, it has to be 1-to-1. That inverse is found by just reversing the x and y values, which is what that definition says. So let's kind of review a couple components of inverses before we talk about how those relate to our trig functions. If you're talking about an inverse, the x's in the original become the y's in the inverse because x and y flip. So the domain of the function is equal to the range of the inverse. Do you remember using that f-1 for inverse? And that means the range of the original function, so the y's in the original function, those become x's. So that's the domain of the inverse. In terms of looking at a graph, finding an inverse reverses x and y, so they are always symmetric across the line y equals x, that identity line, as you flip those ordeals. So do you remember how we found an inverse back in algebra? First step, if it was written in function notation, we changed that fx to a y. Then we would switch the x and y, the definition of an inverse. And then we wanted to turn it back into function notation. So then we would solve for x, solve for y, and then at the very end, we would change that y to f inverse of x to show that we had found the inverse. All right. So far, all of this is algebra review. What's an inverse? How do we find it? Domains and ranges, all of that. But now we have to think about how do we connect this to our trig functions. Okay, we know only 1-to-1 functions have inverses. We also know our trig functions are periodic. They keep repeating, right? We graph sine from 0 to 2 pi, but it doesn't stop at 2 pi. It keeps going forever and ever. If you think about the graph of sine, remember when we did that back in chapter 4, it looks like this. Does that even pass the horizontal line test to start with? No. And then it keeps going. You could keep going forever. And so it most definitely is not a one-to-one function. So in order to find an inverse, we have to restrict our trig functions. We are going to take a portion of it that shows us the entire graph, but is one-to-one. So for instance, on my sine function, if I took this little section here, does that hit every y value my sine graph hits? Yes, and it's one-to-one. So what we'll do is pick 2 consecutive quadrants. The first quadrant will always be one of them because everything's positive in the first quadrant. So we'll have a quadrant where it's positive and a quadrant where it's negative. Now if you think about sine, okay, if I'm going to pick 2 consecutive quadrants, your options are you can do quadrants 1 and 2, or you can do quadrant 1 and 4. We need a positive quadrant and a negative quadrant. Well, would 1 and 2 work for sine? No, because sine is positive in quadrant 1, and it's still positive in quadrant 2. So we would have to pick 1 and 4, because sine is positive in quadrant 1 and negative in quadrant 4. Okay, so we're basically picking, think about your circle, you need a positive and negative. So either 1 and 2 or 1 and 4, depending on the trig function. Then if we take just that portion, we'll be able to find an inverse, because that portion would be one-to-one. So we're going to go through the trig functions and kind of talk about how we do those. So the notation for an inverse is that -1. Sometimes with trig functions, you might see it written as arc in front of it. So arc sine, arc cosine, again, just means the inverse. ACT sometimes uses the arc notation. So it's found by reversing x and y. Okay, if we think about sine, the y values normally go between -1 and +1. That's the range. So that becomes the domain in your inverse. The x values will only go from -1 to +1. I think that's one of the blanks you have to fill in. The range, okay, we know sine, the domain is everything. It keeps going forever. But we talked about if we want to get the positives and the negatives, we have to go with quadrants 1 and 4. If you're trying to describe that to me, so from 1 to 4, we know this is pi over 2. We're used to calling this 3 pi over 2, but another notation is the negative angles. Remember, negative angles spin down. So it's more common to say it goes from -pi over 2 to +pi over 2. And that becomes the range of the inverse. Now, I'm giving you the domain, the range, the graph, just so you've kind of seen it. Our focus is going to be on evaluating these. So the key, the one thing that you really need to know from this slide is these quadrants. Okay, this is the main piece here. You need to know what quadrants each inverse exists in. So the rest of it I'm kind of putting up here for your information, for our discussion purposes, but the important part is sine inverse has to be in either quadrant 1 or 4. All right, so let's talk about cosine. Well, actually, I think I put some examples on before I did my cosine, so we'll try some of those. Okay, I want to find y for each of these situations. Okay, y equals arc sine of 1/2. If you don't like it written this way, what that means, if you rewrote it The only way to move this arc sine to the other side is to make it regular sine. It's like saying sine of y equals 1/2. You have to tell me what y is. Okay, do you guys have a copy of your unit circle handy? Let me just talk about it. Okay. So, on your unit circle, sine was your y value, right? So it's like saying, tell me the angle where your y is equal to 1/2. And if you're just looking at your circle, it happened at pi/6 and 5 pi/6. How do I know which one is my answer?
Because we decided to use
Yes. Since the original problem had arc sine, that's the inverse. As soon as I see that, I know I can only be in quadrant 1 or 4. Since 1/2 is positive, it had to be in quadrant 1. So I'm just saying, tell me the angle in quadrant 1 that makes sine equal 1/2. So if you're looking at a circle or doing your hand trick, sine is 1/2 at 30 degrees or pi/6. And I would usually in the directions tell you if you were in degrees or radians. You wouldn't have to give both.
That's wanting the inverse of.
Yes, so the inverse is an angle. Alright, sine inverse. That just means arc sine, so we're just finding the angle of -1. Okay, we know sine inverse. As soon as I see that, it tells me it could only be quadrant 1 or 4.
It's gonna be quadrant 4.
Yeah, it's negative. Okay, another way of thinking about it, you don't have to write this, but you can. It just means sine of y equals -1. Tell me when y is -1. So if you're looking at your unit circle, where on your unit circle is the y value -1?
270 degrees or 3 pi/2.
Mm-hmm. Just for reference, when you are doing these problems, if you're checking in the back of the book, instead of 270, they'll call it -90. So 3 pi/2, they do -pi/2. It's just a notation thing. We know those are coterminal, so does it really matter which one you write?
No, but it's
No.
prettier.
It's prettier. So just know I don't care whether there's 4 possible answers you could write. They all represent the exact same point on the circle, and I'm okay with any of those answers. All right, C. Y equals sine inverse of -2. So sine inverse tells me it's 1 or 4.
Quadrant 4.
Quadrant 4 because it's a negative. So I'm just saying, tell me when sine is -2.
540 degrees. Or reduced to like the 270.
Well, but sine's -1 there.
So we have to go around another 2.
Think about the graph of sine. What's the lowest value on that graph? -1 and the highest?
Was what?
Can sine equal 2? No, sine can only be things between -1 and +1. If you tried this on your calculator, you would do sine inverse, so you hit second sine of -2, and it tells you, error, domain. It is not possible. So this one does not exist. You can't do that. Right. Do you guys understand what an inverse is doing?
Yeah.
So let's talk about cosine. So cosine to the -1 or arc cosine, those mean inverse. Just like sine, cosine can only be things between -1 and 1, so the domain of the inverse is -1 to 1. Let's talk about quadrants. We know it's going to be quadrant 1 because it's positive there. When is cosine negative?
Inside or tangent. So you're gonna wanna do quadrant 1 or quadrant 2.
Yes.
This one.
We never use quadrant 3 with these. It's always 1 and 2 or 1 and 4. It's positive in both 1 and 4, so that's not an option. So our quadrant would be 1 and 2. And if you think about your circle, This is 0, and this is your pi, so the range is 0 to pi. But again, the important piece on this, the quadrants. You've got to know that part in order to be able to solve these. So let's try a couple. Y equals arc cosine of 1.
So you're just wanting the cosine of
Yes. So this cosine of what equals positive 1. As soon as I see that arc cosine, I know,
it's gonna be in quadrant one.
right, my options are 1 and 2 for cosine inverse, but because it's positive, it's got to be quadrant 1. Think about your circle. When does cosine equal 1?
0 degrees or 360 degrees, 2 pi.
So you could say 0 degrees or 0 radians. You could say 360 degrees, 2 pi radians. These are all coterminal, so lots of different ways. You wouldn't have to give me all of them. You just have to have one answer. So cosine inverse. That means my options are quadrant 1 or 2. Which quadrant would we be in here? 2, because it's negative. So what this means is cosine of some angle y is equal to a negative radical 2 over 2.
135 degrees and 3 pi over 4.
Right. You can think about your hand trick when cosine's radical 2 over 2. That's a reference angle of 45. So 45 degrees in quadrant 2, 180 minus 35, or 45 is 135. Or 45 is pi over 4, so in quadrant 2, that would be 3 pi over 4. If you're looking at a circle, you're looking in quadrant 2, when is the x value negative radical 2 over 2? You guys, are you understanding where we're getting these? Cosine inverse y equals cosine inverse 1/2.
It's gonna be quadrant 1. And it's gonna be y equals 60 degrees or pi over 3.
Because of the cosine inverse, my options are quadrant 1 or 2. Since 1/2 is positive, we're going with quadrant 1. This means cosine of y equals 1/2. So, in quadrant 1, when is cosine 1/2?
60 degrees or pi over 3. I'm genuinely am probably gonna ask for
A blank circle. It's very helpful. If you can fill out your
Oh, my
circle,
circles.
then you've got it all right in front of you. All right, let's go ahead and go through the other 4 functions. Tangent, if we're thinking about quadrants, tangent's positive in 1.
then it's positive in 3.
So it's negative in both 2 and 4. So technically we could use either of them, right? Think about when we graphed tangent. Remember those tangent and cotangent were weird? And we picked it so we would have asymptotes at the end. So do you remember where we graphed tangent from?
Can you check a paper? We graphed tangent from negative pi to pi.
And well, that was the first time. And then we kind of narrowed it down and said if we just need one period, if we just go from negative pi over 2 to positive pi over 2, we get one full section of the graph. So negative pi over 2, that would be quadrant 4, right? So we are going to go ahead and stick with that. It's actually defined in quadrants 1 and 4, just like we used when we graphed one full period. Domain, if you think about the range of regular tangent, it goes up and down forever, so that becomes your domain. Your range, because of the quadrants, we're going to go from negative pi over 2 to positive pi over 2. The important piece being the quadrants on these. Okay, cotangent. When we graphed it, where did we normally go?
0 to pi.
0 to pi. So that's quadrants 1 and 2, just like cosine. So domain is negative infinity to infinity. Range 0 to pi are quadrants. The important piece here, we are going to go from quadrant 1 and quadrant 2. All right. Secant. Secant is the reciprocal of cosine. So it's going to do the same thing as cosine. So that means what quadrants would I use?
1 and 2.
Mm-hmm. Domain and range are a little bit weirder on this one. You think about when we did secant and cosecant, we said it's the opposite sine and cosine, so it hit everything except what was between -1 and 1. So that becomes the domain of this. The range, because we're doing quadrants 1 and 2, it goes from 0 to pi. And the last one, cosecant is a reciprocal of sine, so
It's going to be 1 and 4.
yep, it does what sine does.
Bless you.
Thank you.
You're welcome.
So, to summarize, you need to know which quadrant you're dealing with if the original problem starts with an inverse. Sine, its reciprocal, cosecant, and tangent are all 1 and 4.
And then cosine, secant, and cotangent are 1 and 2.
So think about like these cos. Cosine and cotangent are the same one, and secant always goes with cosine because they're reciprocals. So this is kind of our summary. Everything we've done boils down to knowing which quadrant option. All right. Let's do some problems. So find the degree measure, so you don't have to give me radians on this, of theta in the following. Okay, if the original problem has the arc or the inverse, that's when we limit our quadrants. It's based off the original problem. So arctan, tangent inverse, what quadrants do we pick?
1 or 4.
It goes with sine, 1 and 4. Okay, what this means is tangent of some angle equals 1. We're finding that angle. If it's a positive 1, which quadrant would we use?
Quadrant 1.
Okay,
And it's going to be 45 degrees or pi over.
right. If you think about your hand trick, tangent square root of the top over square root of the bottom. We're in degrees, so tangent is 1 at 45 degrees. Okay. Secant. So secant inverse. When I see that, what quadrants can that be in?
Quadrant 1 or quadrant 2. No, 4. Wait. Give me a second. 1 or 2.
Secant's the reciprocal of cosine, so that's 1 and 2. But this is a positive 2, so we're again in quadrant 1. Okay.
But you can't have, right?
Well, sine and cosine. So this is saying secant is equal to 2. Now, secant and cosecant are a little harder for us to think about in general, but secant is the reciprocal of cosine. So that means cosine is equal to what? Yeah. We're in quadrant 1, when is cosine 1/2?
60 degrees.
Sometimes we have values that we don't know, and we have to use our calculator. But you have to be very careful on your calculator. The issue really comes into play with tangent and cotangent, because we don't have a cotangent button. But tangent inverse and cotangent inverse are different quadrants, right? So our calculator can give us the wrong answer in some of those scenarios. So what I am going to tell you is use your calculator to get the reference angle. So never enter a negative. We'll always do the positive to get the reference angle, and then we'll put it in the quadrant we need. Okay, so let's talk about how we could find these on our calculator. Now, a lot of times I'll tell you, if it's something off your unit circle, I'll say the exact value. So that means don't give me the decimal off your calculator, give me the value from our unit circle. But if it's something that's not on our circle, we'll go to the calculator. So when I see cosecant inverse, I know cosecant is like sine. So that's 1 or 4. Since it's negative, which quadrant are we in? 4. Okay, so what this means is cosecant of some angle is equal to negative 3. Okay, if I wanted to, cosecant is the reciprocal of sine, so that means sine is what? Do we know when sine is 1/3? Okay, so we're going to use our calculator. Now, first of all, I said radians. So change your calculator into radian mode. All right, then I told you don't put in the negative. So on your calculator, I want you to type sine inverse, so second sine of positive 1/3. So this is our reference angle. It gives us 0.3398. So we've done these before, it's just been a while. Now I need to put that in quadrant 4. So we're in radians. I basically found out that this little thing is 0.3398. We need the rest of it. What would you do to get that? Except we're in radians. So instead of 360, we do 2 pi. So you're going to do 2 pi minus 0.3398. If you were checking this one in the back of the book, they would have said negative 0.3398, which is equivalent. You just spun down. So these are coterminal, and just know that I don't care. Either answer is okay. Let's try another one. Find theta in degrees if theta equals arc cotangent of negative 0.3541. So if it's a negative, which quadrants am I in? Or sorry, cotangent inverse. Let's start there. You could be in quadrant 1 or 2, but since it's negative, we're quadrant 2. What this means is cotangent of some angle is a negative 0.3541. Okay, we don't have a cotangent button. We're going to have to do tangent, so that means tangent is the reciprocal. On our calculator, what mode should we be in?
Degrees.
Flip over into degree mode. And And to get your reference angle, you will do tangent inverse, so second tangent of the positive, 1 over 0.3541.
70.5009.
Okay. How would I put that in quadrant 2?
You do 180 minus the
Good.
70.5009.
Is that one okay? Alright. Have I thrown too much at you? Do we need to stop for today, or do we want to finish it? We're gonna have some work time tomorrow, so I can either do last type of problem tomorrow, or we can go ahead and do it now. You guys-
Go ahead and do it now.
You guys good with that? Alright. So the last thing we have, I'm telling you to do these without a calculator. Sine of tangent inverse 3/2. Okay, let's start on the inside. Tangent inverse 3/2. Do we know when tangent is equal to 3 over 2? No. So I can't even figure out the angle. Okay? Let's talk about it. Tangent inverse. What quadrants can tangent inverse be in?
Quadrant 1 and quadrant 4.
Which one is it in?
Quadrant 1.
Okay. The purpose of an inverse, when we're solving these inverses, we're finding an angle. So this tangent inverse of 3/2 is just some angle. What we need to do is find sine of that angle. So let's draw our triangle. In quadrant 1, that tangent inverse of 3/2 means tangent of some angle equals 3 over 2. So we can set up our triangle. Opposite over adjacent. Can you find your missing side now? A squared plus b squared equals c squared. So my hypotenuse is the square root of 13. Okay, I still don't know the angle, but I can now do sine of my angle. Sine is opposite over adjacent, or opposite over hypotenuse. So 3 over the square root of 13, or 3 radical 13 over 15. And again, the reason I did that is because my original problem had both a regular trig function and an inverse. Are you guys okay with that? Last problem. Same thing. When I see cosine inverse, what quadrants can that be in?
1 or 2.
Which one is it in?
2.
2, because it's negative. So this cosine inverse of negative 5 over 13. I don't know when cosine's negative 5 over 13, but I know that's just giving me an angle, and my goal is to find tangent of that angle. So we can draw a triangle. We're in quadrant 2. We know that cosine from that angle is negative 5 over 13. Cosine is adjacent over hypotenuse. So find the missing side. Since it's going up, that side would be a positive 12. So how do we do tangent? So 12 over negative 5. Negative 12 over 5.
Any questions for me?
So I'm going to go ahead and give you homework. You don't have a ton of time, but you could probably do a little bit. And we will have class time to work tomorrow as well. So 1 through 6, 14 through 16, every other even, and problem 79.